Hello, you are most welcome. I'm teacher Ivan from Wuna Educational Services. In today's lesson, we shall be looking at the calculations on density. And if we may call from the definition of density, which says that density of a substance is the mass per unit volume of that substance. So from that definition is where we shall get the formula and the units of density. So from the formula, which is mass over volume, mass is calculated in kilograms as the SI units, and volume is calculated in cubic meters. And therefore, that gives us density as mass over volume in kilograms per cubic meter. However, as we discussed earlier about density, we also saw that density can be measured in grams per cubic centimeter, whereby the mass will be in grams and the volume will be in cubic centimeters. So that gives us another unit of density, which is grams per cubic centimeter. But we saw that in our previous lessons. If at all you missed, please go to our playlist, go to Senior 1 and 2 Physics. You'll find those lessons. Watch them so that we move together. Let us look at some of the calculations on density. Number one gives us the mass of a 24 cubic centimeter of mercury as 332 grams. And they want us to get the density of mercury. So, since density is mass over volume, therefore, we shall substitute for mass and volume, where the mass is 332 grams and the volume is 24 cubic centimeters. So that gives us 13.6 grams per cubic centimeter. Now, members, if at all you are given volume in cubic meters and mass in grams, please, you should change either the volume to cubic centimeters or the mass to kilograms. Otherwise, grams go with the cubic centimeters and kilograms go with cubic meters. Don't mix up one of grams and maybe with one of kilograms. That is our example 1. In our example 2, it's where we are given the mass of the solid and the dimensions of the solid. Assuming this is a regular solid whose dimensions are given as 10 centimeter by 5 centimeter by 4 centimeters. Therefore, for us to get density, we must have the mass and the volume. We are given the mass, but we are not given the volume. However, we are instead given the dimensions. So we shall use the dimensions to get the volume. We know that the volume is given by length times width times height. So we shall not need to identify which one is length, which one is height, which one is width, but we shall just multiply the 3 dimensions of the solid to get the volume. And after, we shall get the mass, which is 800 grams, over the volume, which is 200 cubic centimeters. And that gets us the density of 4 grams per cubic centimeter as our density of the solid. Let us look at more examples that involve calculation of density. We have example 3. In our example 3, we are given the density of copper as 8.9 grams per cubic centimeter, and they want us to get the mass of 100 cubic centimeters of copper. So we know that density is mass over volume, but this time we are aiming at getting the mass of copper. So we can make mass the subject. Density is represented by rho equaling to mass m over volume v. So if we want to make a mass, or we want to get mass, we can make it the subject by multiplying through by volume. So when we multiply through by volume, this gives us times volume, and this one will cancel out, so that we get mass as volume times density. Therefore, our mass is given as density times volume, and now we shall multiply the density, which is 8.9, and the volume to get mass in grams. That is our example 3. Let us look at example 4. In example 4, we are given a measuring cylinder that has water level of 13 centimeters. Then that's the level of water in the measuring cylinder. Then they want us to determine the new water level if 1.6 grams of a metallic solid of density 0.8 grams per cubic centimeter is added. So, members, what happens if we add this solid block into water in a measuring cylinder? The water level will increase. But they want us to determine the new water level in the measuring cylinder. So, the new water level will be the volume of the solid plus the initial volume in the measuring cylinder. So that means that to get the new water level, we must first of all get the volume of the block and add it to the initial volume in the measuring cylinder. And therefore, since density is mass over volume, this time we want volume. So we shall make it the subject, whereby volume is mass over density. So we shall get our mass, which is 1.6 divided by the density, which is 0.8, to get a volume of 2. Meaning that the water level will increase by 2 from 13 to 15 centimeters. Now don't mind about the tube, because the water level in the measuring cylinder, or the volume of the water in the measuring cylinder, is represented by the height of the water level, or the height at which the water level is in the measuring cylinder. So mean that in the question we are having 13 centimeters as the water level. So this 13 centimeters is representing the height, which is also volume. So we shall just get 13 plus our 2 to get the new water level, which is 15 centimeters. Those are calculations on density. Now, after looking at those 4 examples, I want you to also try out some numbers on the calculation. But before we do that, we shall first of all look at the density of mixtures, and I beg that we look at this in our next lesson. Otherwise, I'm teacher Ivan from Wuna Educational Services. Please subscribe to our YouTube channels, follow us on TikTok, we are on Twitter or X, we are on Instagram, we are on Facebook. Search for Wuna Educational Services and make your learning easy and enjoyable. Otherwise, we meet in our next lesson.